Remind you the agenda today, questions on the last assignment and review 1. And then Monday review 2, Tuesday test, chapter 2. I wanted to also tell you I added a new feature to stuff that's available for you. Up until now I've been keeping my grades on a specially designed spreadsheet and then using that to send you grade reports. I'm still doing that, but I also finally, after about a 5-hour intensive session, finally figured out how the MyWLC grades work. And I've been doing software for 25 years. It just doesn't work like my brain works at all, but I finally figured out what they want. They got a module called, what is it called? Coursework. They got another one called Gradebook, and I found out you have to go back and forth between Coursework and Gradebook about 9 times to get the grading file set up, and that makes no sense to me. But anyway, I now know how to do it. So the bottom line is, you can also go look at your grade now in this course, which you weren't able to do before. And then I'll be interested to know, I don't know, for the moment I'm going to just keep doing both, but maybe in the future, I don't know if I should just keep doing what I'm doing, or when I get the things corrected, instead of sending you a grade report, I might just send you an email saying the grades are now posted based on the quiz, and then you would have to go to MyWLC and look. You know, see what you think. Anyway, they're both available for the moment. So for the first time, you could go on there. I'm sure you've had some other professors who have put their grades on there. Am I right? Yeah. But not many? Is that right, too? That's what I thought. A few? Yeah, well, I can see why not many are doing it, let me tell you. Wow. But anyway, it's weird. Once you know the ticket in, it's not so hard, but it's still not logical. So anyway. Questions on 2-7? Emily?
For 29.
Yes?
Why? How do you?
Does the function have an inverse?
Well, yes, but I don't know how you know that.
Yeah, here's what they wanted you to think through, and this is what we rushed a little bit at the end of the class, so it's partly my fault. Does it pass the horizontal line? I know you don't normally think of this, but does this line in number 29 pass the horizontal line test? That is, if you put a horizontal line anywhere through the graph, would it ever cross the graph at more than one point? It wouldn't. So it passes the test. That tells you it's going to work. Now, actually, here's what's going on. You guys also remember this from yesterday. Given a graph, how could you find the inverse? Well, isn't it the mirror image based on the identity function? And so you could have also made a mirror image and just looked to see if that was a function. And if it was, that would have done it too. But the quick way now is, since everything's rotated 90 degrees, you could actually just give the original function a horizontal line test to find out.
So the horizontal line test
Tells you if it's one-to-one. Tells you if its inverse is a function. That's the same thing as saying it's one-to-one. So, on number 29, yes, its inverse is a function. Therefore, yes, it is one-to-one. 1-TL-1. That's what that's all about. And I only spent a few seconds on that. Yes?
49.
Okay, 49. So you were supposed to find the inverse and then graph both the function and its inverse on the same set of axes. All right, so on the left, I found the inverse. Did the swap. Notice I had to, everybody please notice this. Not only did I have to change the x to y, but I had to change both x's. I had to change the y to x. I had to change both x's into y. Okay. Now this is a problem. How in the world are we going to solve for y? Well, here's what happens. Then I cross multiply, I multiply both sides by y minus 2. Cancels on the right. Bunch of horsing around. The bottom line is, I was finally able to get down to this line. And then I said, wow, how in the world can I get that y out? I got two y's yet. Turns out factoring was the key, because I could factor a y out of that. Now, that means I could divide both sides by 1 minus x. All right. So, I actually I did really solve it for y. So here's what my inverse looks like. Now, which one is which up here? I'm going to guess the red one is the original, and the green one is the inverse. Now, you may look at that and go, those are mirror images? And I think if you saw, I put the, here, let me sketch the identity function in there. If you look closely, you really will see I do have mirror images. Hard to see that green, I know. So anyway, that was kind of a little bit of a tricky algebra thing. Are you seeing them both on there? Yeah, sometimes when I go to the syntax here? Yeah. How do you have, can I see, how do you have your, I just clear it. Well, maybe you do that after too. Maybe it's the way you're writing one of those, I don't know. Are you using the negative 1 exponent notation? I was just wondering if anywhere you use the negative 1 exponent in your, no, okay. Well, we'll look at it after. Next question. Michelle. How would we graph 41? And you mean the original or the inverse? Okay. Well, let's just do it, and I guess that's about the only way I know to answer you. Okay, the original is x to the 5th minus 2. So, in our quest to find the inverse, we're going to first put a y in for f of x. Now we're going to swap the x and the y. Now we want to solve for the new y. So we got to what? Take the 5th root of both sides. So or we could have written it this way, Michelle. We could have said x plus 2 to the 1/5 power. By the way, it is kind of interesting to note that since this is an odd power, an odd root, it's going to be legal to do it to negatives. You know what I mean? You can't take a square root of a negative, but you can take a cube root. You can take any odd root of a negative, but you can't take an even root. Since this is an odd root, we don't have to worry about negatives. Okay. So now the question is, how do we graph these things? So I'll just show you on Graph, that software. Pull this down enough so I can see what's going on. Let's see, there's my second one. Okay, so function The first one is x to the fifth. That's where I use that little caret for exponent, minus 2. And I'll have to change the color on this one. X plus 2, caret, and now we'll just put 1/5 in parentheses. Oh, I forgot to change the color on that one. Let's see, how do I do that now? Well, anyway, I don't have two different colors, but we can, isn't that a cool symmetric image? You can see if you put the identity function in there. So, did that help? Yeah. Well, yeah, you're right. We're outside the bounds of the library. But let me just say this. In fact, this fits with the fifth power, too. Why does the fifth power only turn out this looks more like a cubic, doesn't it? Remember, this is imperfect, but what did I think I told you the term rule. The term rule says, take the degree, subtract 1, and that's the maximum number of terms. So in the case of a fifth degree, it would be a maximum of 4 terms. Well, technically, there's only 2 terms here. I say maximum of 4 terms. That's the problem. We don't know. So it could have been, but it can have less terms in there. And so there's not a real great way to predict higher powers, unfortunately. The library works kind of when they're lower powers. There won't be a heavy emphasis on that because that would be non-manual, and I don't do a lot with that, almost none. So in that regard, you're right. However, I might pick something that, like let's say y equals x squared. Everybody knows what that looks like, and its inverse, which looks like this. And there's the case where I wouldn't feel bad about doing that manually. So. Yeah, did everybody get that? She asked a good question. She's starting to get into my typical testing ways, and she's right. I don't ever write a test that's going to be heavy on technology. I can't. I didn't require a calculator from all of you. Okay? I didn't. But on the other hand, do I not allow them? No, I allow them. So you can keep operating the same way. I'm just going to tell you that as you probably already know, I design my questions so they can be done and really need to be thought through manually. And then if you want to use your calculator to check it or something like that, yeah, you can do that. Mm-hmm.
So on the test, if he forgets, if he has a test, can we use it?
Yes, I'm not going to. Yeah, except I'm not likely to give you a problem like this on the test because this one kind of requires the calculator. You're not going to see questions that require a calculator from me. That doesn't mean you can't, but you want to use them to check? Sure. But I'll warn you, if you depend on a calculator to think through this stuff, that's probably going to cause you a little bit of trouble because my questions will be aimed at, does this person really know what's going on without the calculator? That's the way I aim things. So it's just kind of a strategy question, and since we're getting close to test time, it's good that we think about that. So other 2.7 questions. Yes, Liz. Hold on, I should choose.
Sorry.
Okay. How you take what they gave you and? Okay. I honestly, in this case, since there's there's only, what, 6 points? I plot the points. And, or maybe even better, no, I'll tell you what I do. Doesn't have an inverse, all you gotta do is take all the points and reverse them, right? Isn't that what an inverse is? So instead of -1, -2, the inverse is -2, -1, 1, 0. Here, let's just reverse those and write them down and take a look at them. Okay, so 25. Yeah. So I'm just going to reverse the ordered pairs. What do we get? -2, -1. Next one is 1, 0. 2, 1. 1, 2. -2, 3. -6, 4. Now, I put it to you. Do those points make a function? Now, that's one of the skills you're supposed to have in this chapter. If I give you a set of ordered pairs, you should be able to tell if they're a function. I heard somebody say no. Yeah. Why not?
Because there's two places where it'd be -2 and on one hand, and on one hand, 3.
Yeah, and there's 2 places with 1s, too. But that's all you need is 1 violation. So this is not a function, so the answer to that one is nope. So what you when they give you a set of ordered pairs and they want to ask you about an inverse, just literally reverse them and then judge, is it a function? So that was number 25. Another one? If not, we can start going into chapter review. I mean, I'm, yes.
Just for more clarification,
Uh-huh.
the one that we just did,
Yes.
that chart is a function, right?
The original one, yes. Thank you for asking that. That's a good point. Is the original set of ordered pairs a function? She says it is. Is she right, Liz? I caught you chewing again. Sorry. If you take the original list of points, is that a function? Yeah, I know. Well, they said it is. I don't believe them. They told the truth, though, didn't they? Because if you just look at the original list, did they ever repeat an x-coordinate there? No. So they're in the clear. So the original set, yeah, that was a function, and they did tell the truth. And so, yeah, to clarify, that's a good point to bring up. So sometimes you can have a function, and when you do the inverse, you can wind up with not having one. Yeah. You know what it amounts to. Is it okay to have points horizontal from each other in a function? Sure. The only thing you can't have is when they're vertical from each other, right? And so in the original one, they got a few points that are like this. That's perfectly okay. But unfortunately, when you do the inverse, they wind up under each other, and that's why it didn't work in the inverse side. So you know by now, what graphical effect does an inverse have? What happens to every, yeah, she did it, she just said, that's exactly right. It takes everything and rotates it 90 degrees clockwise, and that's not a bad way of seeing all, and that's why. If they're horizontal from each other, then we rotate them 90 degrees, they're going to fail the vertical line test. Yeah. Yes? Yeah, let's just see. Anybody else on 2.7? Not that we can't do 2.7 questions later. Sure, go ahead.
From the review.
So the question is, from the...
It's on page 250.
Oh, I see. From the, you mean from the chapter. Okay, page 250. Yeah,
Like page 50.
So everybody, let me just make a comment here. Don't forget, ideally, Monday's class would be more questions like hers or from the practice test in the book. You know, the practice test in the book is not perfect, and as a whole, they're a little bit too long for a 50-minute, well, they're actually quite a bit too long for a 50-minute class period. But the style of questions should be very true to, now you don't want to look at the cumulative test. You want to just look at the chapter test. What do they have, 20 questions? Yeah, that's a little bit too, it's a little too long. I think I only had like about 12 last time. Anyway. Okay, for next time, that's where we're headed. All right, now, you said 88 maybe, and
Well, like, I need you would want.
do you want to pick them? 86? Okay. Okay, so let me just get here so I got it about in the right place. Okay, number 86. On the review. F of x equals x cubed. And g of x, no, h of x is x minus 2 plus 2. All right, now the directions. Identify the transformation of the graph of f and sketch the graph of h. So, what you're supposed to do is look at f and h and see what's similar about them and what got changed. So I see that they're both what? At the heart, they're both cubic functions. And the basic one is on the left. What did they do to the one on the right? Hopefully you're looking at that, you're saying, oh, they moved the 2 to the right, and they shoved it up 2. So here's what I would do now. Did they say sketch both? No, just graph H. So what you want to do is something like this. Nice x-axis. So what you want to do is something like this. You want to say, well, the basic x cubed graph, that looks like this. Approximately, right? Except that doesn't go vertical. Now, let's change colors. Ours, instead of having this point right here, what did we say? It's shoved to the right 2 and up 2. So it's like my new what? Resting point is there. So this graph probably looks something like this. I think that's the idea, and we don't care how precise it is, just that you have the general shape and how it's been moved. Yeah. You mean out in front of parentheses? Yeah. Okay. Let's see. I got to think about that. What, not in front of the 2? Well, that would have caused, okay, because it was on outside the x, that would have just caused a vertical stretch and would have been twice as tall. All the points would have been, so what the net effect is it looks skinnier and it looks taller. Now, had the 2 been on the x, inside the parentheses, then it would have caused almost the same, it would have caused a horizontal shrinking, almost the same effect, very similar. Okay, so there's a review question. I'm storing those up too. I used to have like 2 files, one for review 1, one for review 2. Now I decided that's kind of silly. Put them all in one big thing, and I got them filed under review questions and practice test questions, so we can look at them on either day real easily. Another question? Emily?
Do you need one, like 91 then, or do you need 91?
Sure. Okay. So the original function in 91 is the greatest integer of x. I'm going to just simplify things by just using single brackets, okay? Everybody, when I do that on the test too, if I just put x in a single set of square brackets, I think that notation is, that'll mean greatest integer. And h of x is that negative that plus 6. Okay, so, of course, what does the negative sign do? Well, first of all, what does the greatest integer of x look like? That's that step ladder that goes up along the line y equals x. Okay? The negative does what? Flips it upside down. So instead of going uphill, this stairway is going to be going downhill. What does the 6 do? Takes it and shoves it up 6. Now, let's graph it. Yes?
So negative is out and like, is there any y and
X-axis. Yes. Yes. I don't think you're going to see that too often, but that's correct. Okay, so what does this look like? Well, let's get enough here. I'm going to get it started. Well, I'll tell you what. Let's just do a few points and we'll get going here. Let's have x equals 0. What's the greatest integer of 0? 0. What's negative 1 times 0? 0. And 0 plus 6 is 6. So, there's one of the points on our graph, right? Okay, now what happens when you take something like a half? Okay, the greatest integer of a half is 0. So you're going to get the same point. And 0.9, so these are all going to be filled up. And as soon as we get to 1, what's going to happen? What's the greatest integer of 1? 1. And the negative of that is negative 1. And negative 1 plus 6 is 5. So you see what's happening here. We got our first step, solid dot bar open. Okay, and then this is going to keep going like this. And you can just go backwards. So that's pretty much what 91 would look like. Now, you could check a couple more points. So does it make sense? Does that look like the upside down normal greatest integer? Yeah. Does it also look like it's been jacked up 6 units? Yeah.
Do you really use your graphing thing or
Actually, there is a way. I found out what it is. It's called trunk, which stands for truncate. Well, I don't know if that's on. I don't know, but I don't know what it is on that calculator. That's what it is on graph. But it won't. It's still not going to get the open dots. Here, let me just show you. I think it's trunk. Here. By the way, I did help, and that's how I found out. Let's see if I have it right. Yeah. So here's the greatest integer of x, but it still doesn't get the open dots, you know. And by the way, trunk stands for truncate. But you're not going to get a whole lot of help from technology on that one usually. You can't even see the black bar here. You got to look really close. There is one. Actually, this is wrong for greatest integer, because you notice how the stair changes directions? Take a real close look. You see how the two sets of stairs are not lined up? And I'll tell you why. What this does, it's okay from here on, but what this does is literally just chop off the doggone decimal. Well, that's not exactly what we do in greatest integer. It's okay for the positives, right? If you say, what's the greatest integer of 2.8, it literally chops off the 8 and says 2. But on the negatives, that's not what it does. Because what's the greatest integer of negative 2.8? Negative 3. You can't just chop it off. So you see how this is only half right? Do you see how this is wrong? Like if I cover this part up, that part's okay. So anyway, I probably shouldn't have shown you that, but there are some functions that sometimes I've seen sometimes INT will work. I don't know if anybody in here does programming, but in programming, INT of whatever will frequently work. So you just, yeah. Okay, another. So as on your graphic calculator, there might be a command. What is it? It is it. Oh, it is int.
I think so, but well, I didn't like it.
I might guess int works.
But it's off. It's different than where you have yours.
Can I see your equation?
I made a mistake.
What's your equation? Oh, yeah, well, you added 6. You just got to do negative 1 times that. Up in front. So you would go negative 1 after INT. Asterisk is the symbol for multiplication.
Oh,
Sorry.
okay.
Multiply. Negative 1 times. What is it? I'm sorry. I don't know why I'm talking in asterisk. Then you would get it. Yeah. All right, what's next? We can get this out of our heads now. Should look like that. But again, you don't see the open dots. And you never, I don't think zooming will help with that. I think you're going to just see it terminate. There was some software, I don't know, does anybody use Maple? If you graph in Maple, I think it'll show the open dots. And I can't, what is the command there? Is it INT? It's something else. And I'm not thinking it because at the moment, I haven't been able to use Maple for a year and I've lost a little bit of it. But there's another command and it's not int, it's, yeah, I don't remember. Well, no questions, huh? We can start doing test questions, or
Let's do the test.
well, they're on page 252. No, going to a technology conference. I haven't decided. I haven't figured that out yet. Sorry. But you got class. We have review Monday. Tuesday we have test. Wednesday, Thursday, Friday, I'm not going to be here. And I said I might do something. I don't know. Maybe I just have not had a chance to think about that. I don't quite know. What I usually like to do. What I usually like to do is, you know, show you your tests right away. So I'm toying around with scanning your tests and attaching them to emails back to you. Because I can, on my online class, I actually do that where I do my correcting electronically in red pen over the top. And so I might that's something that sounds attractive to me. So that maybe what I'll do this time is I'll scan your test, I'll correct it electronically, and then I'll hand it back to you electronically, attaching it to email, and then you could go in there and look, and you could actually see the same thing you normally see, except you got to look at the screen. And I'll send it back to you in a Word file. So if you've got Microsoft Word, you should be able to read it.
You could just submit it in a mailbox, perhaps on it.
That's another thing I could do. The only problem is then I got to have them corrected before I go. And I may be able to do that. Let's see. We're taking the test on Tuesday. I think we're leaving on Tuesday, so that's probably not going to happen. But what I might do is the electronic thing. The only problem with that is if you're going to ask me a question, you're going to have to ask me your question electronically or wait till I come back. So I was thinking about maybe then possibly on one of the 2 days, not both, but on one of the 2 days, having you just read ahead, look at my website, which is already there, and do an assignment. I might still do that, but I haven't decided. So anybody want to do like a chapter test question or something? On the chapter test? No, not that one. Yeah, certainly. Bad joke. Yeah, we can do number 5. Sorry. This is a bad joke, Emily. Okay, here's number 5. Directions. Evaluate the function as a specified value. Hey, Emily, you asked this question. Now you got to hang in here. So if they ask you in Part A to find f of 7, all I did was, like a good algebra student, I substituted 7 in wherever there was an x, and I got 16 on the top, and I got 49 minus 81 on the bottom, and it led me to come out to, if I simplified it, down to negative 1/8. So really, these are just substitutions. No, that's all. Now, they get a little uglier when you do Part C, right? Because there they ask you to find what's f of x minus 9. Wherever there's an x now, I got to put an x minus 9. And you know, what I've seen from students is, students have a tendency, like when they do this part right here, I've seen a lot of students do this. They say, well, if x is x minus 9, then x squared must be x squared minus 81. No, because what is x minus 9 squared? It's x squared minus 18x plus 81. I'll forget about that middle term. So I'd rather just, yeah. So anyway, you got to remember, just be careful you square that whole thing. And there's a limit to how far you can go here. I mean, I couldn't simplify any more than that, so that would have been it. I guarantee you that this kind of questioning will be on the test. This is so important to this chapter, to be able to understand function notation. So this style, I don't know, something like this has got to be on there. Not necessarily this problem, but that concept. Yeah, that's a biggie. Another one, guarantee you will be on the test, is find a difference quotient. Sure, we can do it. You want to pick one? Now, they may not use that wording, or do they? Did they even put one on there? Shame on them if they didn't, because that should be on there. Oh, not good. I was doing this to the book. Shame, shame, shame. So somebody want to pick a function? It's a new game show coming out soon. Pick a function. All right, well, here we go. Anybody want to pick a function? Probably. 9 in the review, you say? 49. 49? Yeah, should we do that one? Okay. So this is 49 on the review. Yeah, that's a good example right there. We've got f of x equals 2x squared plus plus 2x, no, plus 3x minus 1. And find the difference quotient. Okay, now everyone, first of all, has to know that what do they mean when they say find the difference quotient? That wasn't quite right. That Homa. Yeah, f of x plus h minus f of x all over h. I heard it a couple places. So, what do I need to find before I can do all of that? I need to find f of x plus h. So, step one always is this. What in the world is this? So, wherever there's an x, I got to plug in an x plus h. Whatever I did to x, I now have to do it to x plus h. So here's the important first step in doing that. Substitute it in. Now, do whatever the calculation requires. Okay, this is x squared plus 2xh plus h squared. We can do this distributive property. And then I just have to multiply out the 2. So we've got 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 1. Does that look right to everyone? Okay, so that's now we're ready to go. This is the f of x plus h thing. So let me just write down the difference quotient like was stated in the back there. This is what I'm trying to find, right? This is our goal. Okay, in this case, what is f of x plus h? It's this big old long thing. See if I can write it a little skinnier so I have room. Minus the original function yeah, if you want to carry out the distributive property right away, that's a good idea. So now we're down to that. Now it's just a little bit of algebra. The 2x squareds are going to go bye-bye. The 3x's are going to go away. And minus 1 is going to wipe out with that one, correct? That'll always happen where you'll be able to eliminate some things on the top. And now you can see what's left. Every term has an h in it, right? 4xh, 2h squared, 3h. So let's right away factor an h out of the top. And then if you've done your work right, you will be able to do this cancellation every single time. And that's the signal to you that you have arrived. When that h goes, you've got it. And the final solution here is 4x plus 2h plus 3. And it's really important to me that I see your work on this problem. Yes? Yeah, I kind of did two steps at once. I took what was left up here, these three terms, and I saw that they all had an h in them. So instead of just writing it, I thought, why don't we factor it out right away? And then I knew, because we know we're going to cancel in that last step every time. So I took a little bit of a shortcut there so I could fit it on the screen better. Yeah, that's a huge, guaranteed. There's going to be a problem that has difference quotient in it. So really, there's no reason you shouldn't be able to nail that one. Now, what's that? Maybe two, not more than that, but I don't know. I would say probably one, maybe two. Now, the other kind we should maybe do, we don't have to do it right now because I want to do what you want, but I want to just say this. We should probably do a root problem of the difference quotient because they have their own little flavor to them. Well, I don't want to, what was your question going to be? Yeah. So anyway, Emily, just remind me, maybe we can do that Monday. We should do a root difference quotient. Or anybody remind me of that. Okay, the question was, what about a piecewise graph? Okay, here we go. So you might get a function like this, where I give you the equation. You're always going to see a bracket of some kind because it's got to break it into at least, I'll do it this way. Okay, let's say it's x when x is negative. It's 2 when x is 0. And it's so I'm going to just make 3 pieces, okay? That says, that's supposed to read negative x plus 3 when x is greater than 0. Okay, grid. Okay, so do you get what's going on here? It says, hey, when you're negative, this is just a good old identity function. So what I'm going to do here is, I don't want to include the origin. And then from there, please excuse the color, that should probably be blue. It's going to look like that, and then it's going to stop at the origin, and when it's 0, then the answer is 2. And when it's positive, then the answer is negative x plus 3, which looks like this. Now let me just get some arrowheads on there. Now, first of all, is this a function? It actually is, because here's the trouble spot, right? But still, I only crossed at one point here, so I'm still okay legal. So when it's negative, it's an identity function. When it's right on 0, then the answer is 2. And when it's to the right of 0, then it's this thing that has the slope of negative 1 and a y-intercept of 3. And so there you got 3 pieces actually on that one. There's a piece 1. Now sometimes one part could be straight, one part could be curved. And if I did that, I'd probably pick something either like this that's straight or something from your library. Like maybe I'd throw it into the positive, maybe I should have thrown in square root. So you would have, to see if you knew your general shape. Have a good weekend. See you Monday. So come with questions Monday. Don't forget we have to do a what? A root difference quotient.